Hi, and thank you for watching my ACS 2021 poster presentation. My name is Dane DeSutter, and I'm a lab solutions developer at Catalyst Education, an edtech startup that focuses on university and community college science lab education. In particular, I work on developing learning analytics for the LabFlow platform. Briefly, just a little bit about me. I received my PhD from the University of Illinois at Chicago in the learning sciences, where I used design-based research methods to understand the role of spatial thinking in organic chemistry. While at UIC, I gained a lot of experience merging together learning environment design and varied data sources to track and understand both student and TA change processes in the classroom. Now at Catalyst, I work with a team of dedicated scientist educators who are working to create the next generation of educational technology, focusing on learning in the laboratory. What I will be showing today is the first stage development of analytics and a dashboard visualization of these analytics that I hope can make it easier for general chemistry lab coordinators and lab instructors to know when grading disparities are happening in their course and providing them with enough information to act in a timely and informed fashion. Understanding grading patterns in science, technology, engineering, and mathematics, or STEM, is a crucial step in improving university science education. One reason in particular is because recent research has identified a phenomenon known as the STEM penalty. The STEM penalty refers to the lower average grades that students receive in STEM coursework relative to non-STEM subjects, and the authors of this study argue that this is a major factor that's driving students away from science. Such grading practices have been primarily well documented in lecture courses, in particular their negative impact. However, comparably less attention has been paid to understanding what grading practices look like in laboratory settings. We do have some evidence from research in physics lab settings about possible grading behaviors and disparities we might expect to see in general chemistry lab settings as well. For example, grading students' work can often be uneven and subjective when the TA sees the content as requiring conceptual versus more procedural or computational knowledge. The assessment format itself can also affect the subjectivity of the grader when a TA sees the assessment as being for specific things like summative versus formative assessment. Interestingly, even when grading practices are subjected to intervention, like implementing rubrics, we may still improve the consistency of grading but not eliminate grading disparities entirely. These papers all suggest that tracking grading is important, and it requires a focus on the TA themselves, as well as their grading across assessment types and time. These studies are all invaluable in improving our understanding of grading practices, but these studies use interviews and analysis of video data, making it less practical for developing actionable insights during a lab course. To address the needs of lab instructors to both understand grading patterns in their class and act on it in a timely manner, I've proposed a few design principles to inform the design of analytics and a visualization dashboard. In particular, the review literature suggests a few considerations. Design Principle 1. Insights should be useful and timely. This means that all information should be presented to coordinators and instructors in a clear and automated way, with data being updated in near real time as grades become available. Design Principle 2. Analytics and visualizations should look at the interaction of TA grading and content domain. Labs can be procedural, focus on instrumentation, and even be more conceptual in nature. This may affect how TAs grade their work across the semester. And finally, Design Principle 3. The dashboard should disentangle data by assessment format. This dashboard was designed in the context of LabFlow. Briefly, LabFlow is a lab education platform that merges together laboratory data collection and analysis into a single digital report format. Lab reports are customized to contain a mix of item types like numeric entries, dropdowns, essays, and file uploads to meet the activity requirements for a given procedure. Reports often contain automatic and hand-graded items. Here we see examples of each type in a report. Some prompts, like numeric calculations on the left, can be automatically graded against students' data. Other items requiring more free-form response, like essays circled on the right, are hand-graded by TAs. Here we can see examples of each design principle instantiated in the interface. Graphics and analyses ingest student data on demand, keeping information relevant and current. Each dashboard element merges together some data visualization and plain text interpretation to provide key takeaways from that data. This makes interpreting complex information comprehensible. Interface elements like the outlier model selector and model descriptions provide instructors with tools to transparently select between clearly explained criteria for identifying grading patterns that may need follow-up. TA grading metrics like their score distribution and section median are shown against the aggregated class dataset. This data is presented at multiple timescales. This includes the current report at the top, within the context of all section meeting times during the week on the right, and to date within the semester on the left. Finally, this visualization shows how scores varied by assessment format between auto-graded and hand-graded items between TAs. Future iterations of this work will also work at connecting TA scores to other assessment items like quizzes and TA-generated feedback. If you're interested in seeing more of the Report Analytics dashboard, please see the demo video provided in the supplemental presentation materials. There are a number of future directions for this work. Briefly, those directions include providing additional item-level analysis to reports in LabFlow. In particular, I'm interested in applications of item response theory toward estimating properties of items like their difficulty, student proficiency, and also rater differences. Here we can see some initial data visualization designs to convey quantitative properties of report data, like item type correlations with report score on the left, and rater stringency estimates against other implementations of a lab activity on the right. Thank you for taking the time to watch this presentation. Again, my name is Dane DeSutter, and I'm a lab solutions developer at Catalyst Education. If you have any questions or suggestions, please contact me at dane@catalystedu.com.